I'll kick off an intro. So, hey everyone, my name is Aparna. A little bit about me. I'm currently one of the founders at Arize. I run product over here alongside Rhea. Arize is an ML observability platform. We focus on monitoring and surfacing up performance, drift, data quality, as well as fairness and bias issues about models to our users. And the higher level goal is the more observable these models are, the more we're able to detect when there is bias about these models. So Rhea on our team is going to kick off a little intro, jump into a little bit about observability, and I'll jump back on and we'll talk about bias shortly. Go for it, Rhea.
Hey everyone, my name's Rhea. I'm head of product here at Arize. Recently came over from Google's research and machine intelligence division, where I was leading product for a suite of graph-based ML tools. And as Aparna mentioned, at Arize, we kind of bring a unique background in terms of a diverse team that has all kind of had this firsthand experience of taking a model from research to production and kind of encountering all the variabilities and chaos that comes with that journey. So I'll quickly just dive right in. I think in this conversation, what I'll do is highlight some of the challenges with productionalizing machine learning. We'll discuss what ML observability is in terms of a practice and some of the key features that you should expect from a good ML observability platform or tool. And then maybe dive into some of the key characteristics of what ML observability is in terms of like drift analysis, performance analysis, data quality, and then I'll pass it back to Aparna for some explainability deep dive. With that, I think general starting point for building any sort of ML model generally begins in some sort of controlled environment. Maybe it's your Jupyter Notebook or Colab environment. And building machine learning concepts in this environment is kind of drastically different than making models work in the real world. And that journey looks different depending on what you're actually trying to productionalize, whether it requires rewriting a model in a different language or how to handle feature transformations in an online environment, or whether answering this question of, is that model even worthy of being in production in the first place? I mean, these models are generally touching kind of key business decisions and driving critical business metrics. And of course, when the model is live, you also have this question of, hey, is it working as expected? I think, it's important to point out, especially kind of, as we're gearing towards this hopefully post-pandemic world, it's very difficult, if not impossible, to predict the type of chaotic environments, changing human behaviors, climates, malicious adversaries that can come with the real world. And so that's the reason I think ML observability has come to be such a hot topic of an increasingly important practice in common workplace, especially as ML engineers are constantly thinking about this. And so what are the common challenges that we see? Here's just, this list is by no means comprehensive, but oftentimes we're seeing kind of model and data drift. So statistical changes in your distribution kind of happening over time. Generally, we see this whether it's seasonal changes or human behavioral changes, performance degradations, whether it's your credit card fraud model that is slowly degrading because fraudsters have found an exploit, model interpretability. So this is especially important in areas of high regulatory and compliance laws, when you need to be able to explain why your model acted in the way that it did, why it made a particular prediction. Perhaps one of the most common challenges we see are data quality issues. So how can you prevent kind of upstream changes in your data quality pipeline from how can you detect that early and prevent critical business metrics from being impacted? And then additionally, kind of as you're iterating on models in your controlled environment, how can you confidently deploy that candidate model, that challenger model into the real production world, knowing that it is better than what's kind of out there already? And then, of course, fairness and bias being a really important topic in today's day and age, to make sure that your model is not biased because of the data that it was trained on, or not making predictions because of certain historical data that it's seen in the past. So there's been this this kind of ever evolving software tool chain where you use GitHub for version control and software engineering, you use Datadog for infrastructure observability. This same type of concept is coming to light across the ML infra stack. You have feature stores kind of handling your online, offline feature transformations. You have the model store serving as your central model registry for tracking experiments. And then some people also have kind of model serving environments like SageMaker, Algorithmia, or TensorFlow. This facilitates that deployment at scale. And where ML observability really comes in is with this introduction of an evaluation store. So kind of like how a model store keeps all your models and model versions, an evaluation store captures your model's inferences, not just in production, but also in offline environments. So training, validation, maybe it's different windows of production across different model versions. And the evaluation store kind of takes care of intelligently indexing, aggregating, and providing fast retrievals to facilitate some of the kind of ML observability features and functionalities I'll go over in just a couple slides. So as I just mentioned, kind of ML observability is really founded on this concept of an evaluation store, indexing all the inferences from your model across different environments and versions. Oh, and one thing I did not mention in the previous slide is we're also, the evaluation store also indexes the actuals or the ground truth that you're able to collect from your users. And I think it's important to define kind of ML observability, as oftentimes a common question comes up is ML observability ML monitoring? And the answer to that is ML monitoring is just one piece or one small sector of ML observability. Monitoring is kind of status indicators. Hey, something's wrong. Hey, everything's looking good. ML observability as a practice is really gaining a deep understanding of your model's health and performance across the entirety of the model development lifecycle. And a good kind of ML observability platform tool set relies heavily on this evaluation store to provide things like data quality checks for anomalous data, for edge cases, for missing or empty values, or type mismatches, provides performance analysis, not just a single statistical metric, hey, this is the accuracy of my model, but really going beyond what happened and drilling down into why your performance has degraded. Understanding your performance, not just at a model level, but also at the granularity of various low-performing cohorts. Hey, your recommendation model is doing great overall, but for middle-aged women in this zip code, your performance is actually between 60 and 70%, significantly lower than that global performance. So really being able to surface these cohorts or slices. And then as I mentioned, and Aparna kind of introduced the conversation, explainability and being able to reduce the time to from the monitoring side, detect and proactively alert. And for explainability, being able to justify or provide some sort of understanding as to what affected your model's decisions. So this slide is just kind of visualizing what I mentioned moments ago, that monitoring is really just a piece of observability. This is perhaps one of the most common questions we get, is kind of, is monitoring and observability synonymous? And as they spoiled it for everyone, the answer is no. So jumping into right away into drift. This will be kind of the first pillar of our ML observability walkthrough. Drift is a change in your distribution over time. It can be, you can measure drift in your feature or your model inputs. So maybe there is a difference in the consumer's age, which is just one feature into your models for your model's predictions. You can measure drift according to your model's outputs. Maybe there's a total shift in the actual predictions that your model is providing. Or maybe there's a drift in the actual values or the ground truth that you're able to collect from your users. So you can really measure drift across a number of different metrics. And it's important to measure because drift is, models generally are trained to perform well on data that they have seen before. And drift allows you to really kind of flag any sort of discrepancies or changes over time that should indicate some sort of retraining is necessary or for your particular model. Now, people measure drift in terms of population stability index or Kullback-Leibler divergence or KL divergence or Wasserstein distance. So there are a number of different ways that people choose to measure drift. And again, it's kind of important because models are not static and they really are meant to perform on data they've seen before. So surfacing this type of drift across feature values and model predictions is critical for detecting potential issues that could happen down the line. So in order to measure drift, one thing to note is that you're actually measuring drift against some sort of reference distribution. So one of the difficult decisions that a person needs to make when specifying this across your ML observability platform is, what should I compare my production values and what I'm seeing across my production data set to? Is it my training set? Is it my validation set? Is it some sort of initial model launch period? And so these are types of questions that really take a second to stop and think about. For example, in the case of fraud is one use case where generally there's highly imbalanced data sets. So commonly what you see in healthcare is less than 3% of transactions are actually fraudulent. In credit card fraud, it's about less than 1%. And so if you're training a model in a training environment and you've upsampled so that your training set has 50% fraud and 50% not fraud, well, if you're comparing some production performance of your model to your training set, you're going to notice a heavy discrepancy from your training set, which has, this heavily upsampled number of fraudulent transactions in the order of 50%, and what you're seeing in production, which is about less than 1%. And so in that particular example, maybe you want to use an initial model launch period to measure that drift, to kind of really understand what your current window or your current performance is like compared to that reference distribution where you knew things were performing as expected. And drift is just one kind of metric used to detect trends. And it's really useful in identifying kind of the overall shape of your data and how it's changing. It's useful in detecting things that we kind of call slow bleed failures. And it's especially useful as a proxy metric if your team cannot collect actual values to really compute some type of performance metrics. Now, what Drift is not good for is kind of these one-off anomalies or outlier detections or measuring consistencies in your data. You know, it doesn't solve everything. And it is important to note that there's not always a correlation between feature drift and your model's performance. So this is just an image that kind of showcases that in a solid ML observability practice, kind of maybe your general flow for troubleshooting drift might be a monitor is triggered, you're alerted of some sort of change in your distribution, maybe it's in your prediction drift. You should be able to very quickly interact with and understand how your PSI metric, your population stability index, is changing and what that looks like across your distribution. Again, comparing your production values, what you're seeing in the real world, to that training environment or that initial model launch period where you knew everything was acting as it should. Jumping into performance, I think kind of performance of models can be categorized into two classes, depending on the availability of ground truth or actuals. This is the happy case. I mentioned kind of a credit card fraud model in a previous example. We've all been at the cash register, swiped, maybe it was a higher than normal purchase or in a city that we're not usually in, and you kind of get declined and that text message comes in, hey, was this you? Is this a legitimate purchase? By quickly responding to that text and avoiding the embarrassing situation, you've provided ground truth to your credit card provider. And so that's a relatively fast actual. Or maybe it's in ride sharing where you call an Uber or a Lyft and your estimated wait time for your car is 10 minutes. The car shows up in something closer to 15. That actual data on the estimated, the actual wait time is a relatively fast actual. And one thing that we see is generally when you have a short delay between predictions and actual values, you can go ahead and compute performance relatively quickly. A solid ML observability toolset should be able to map back these actuals with the predictions to go ahead and compute those performance metrics at scale. And as I hinted at previously, performance goes beyond a single statistical measure. So it's not just surfacing up, what is my accuracy, what's my precision, what's my recall? It's surfacing up cohorts of different feature value combinations to provide insights as to where you have the opportunity to lift your model. Now, the unhappy case, models without fast actuals. Maybe you're in insurance and in using a fairly morbid example, maybe it's life insurance. The only actual you're going to get is perhaps years, if not decades later. In a less morbid example, such as maybe lending, your predictions on whether someone will default on a loan or not could be 90 days out or a couple of years out. And so you're waiting for that ground truth to come back to really be able to accurately compute your model's performance. Now, in this particular case, where you have a significant delay between your predictions and your actual values, it's important that there are creative solutions to kind of measure the unmeasurable, right? So you can go ahead and use some sort of proxy metric, come up with different proxy metrics. Drift is one good example of using of capturing a signal as to whether or not a payment is going to come back in that lending case. We've seen some creative solutions that are probably worthy of their own presentation. on lowering the threshold of your model's predictions and testing some small window where you generally wouldn't issue a loan, but you do so just to measure as a kind of proxy metric whether you were correct in that decision. And this could be used to kind of mitigate the case where you have biased actuals, because just continuing with the lending use case, if you only are able to get ground truth for loans that you issued, how do you ever know if you were correct or incorrect on loans you didn't issue? You don't really have a way of collecting data as to whether a person could or could not repay that loan if you didn't give it to them in the first place. And so kind of just quickly touching on models without fast actuals is probably worthy of its own presentation on creative strategies for proxy metrics and measuring the unmeasurable. You've heard me talk about this a couple times already. Really being able to drill down into cohort predictions and understand the various slices of low performing segments. So what feature value combinations is my model performing subpar on, and what feature value combinations am I confident the model is doing well on? In this case, it might be high net worth individuals, but I'm completely underperforming on people that have defaulted in the past 2 years. So touching on a couple visuals on how to troubleshoot performance regressions as you might see in an ML observability platform or tool set. I think the first thing is kind of, again, being able to proactively monitor dips in performance degradation, being able to evaluate and automatically surface. I'm not talking like writing a set of SQL queries to figure out which performing segments are doing well and doing not well, but really having the ML observability platform do the heavy lifting and surface these low performing cohorts or feature value combinations so that you can inspect, so that you can export that data and go line by line to understand whether you need to upsample, retrain your model, or choose a different type of technique or algorithm to retrain your model. So this is perhaps one of the most common issues we see, kind of bad production data. And it's kind of no industry or use case is immune to bad data. And the importance of data quality ingested is it's very correlated to the predictions of your model in almost all cases. So how do you actually handle bad data? In this example here, I'm taking age as an input to my model, but in some cases, I'm actually not able to collect that. I have some NaN values or none values. And one common thing we see folks do is actually drop the prediction overall for bad data. This in many cases can kind of provide a filtered view on the state of your predictions. We see a number of kind of imputations or filling in some sort of default value for any missing information. The caveat to this is you could kind of create this synthetic drift in your predictions and introduce data leakage if you don't do this properly. And of course, there's the case where you kind of do nothing or throw an error if you're able to keep your users happy while doing so. In a solid ML observability platform, you should really be empowered with early detection for this so that you make sure it's not kind of an upstream set of issues that's coming in. You want to be able to surface any type mismatches, missing data, out of range violations, and cardinality for discrete variables. Additionally, you should be able to kind of monitor any spikes or unexpected traffic and really know what baseline to use. So similar to how drift measured statistical difference between a baseline and your production data set, Similarly, you don't want to have to go in and individually or manually set thresholds for data quality across all of your features. An intelligent ML observability practice will do this on your behalf. It'll use that baseline to go ahead and set up data quality checks, set various thresholds for differences in your reference distribution to your production data set. And finally, moving on to explainability, I'll pause quickly and see if Aparna wanted to jump in on this. I know she mentioned she may wanted to comment here. If not, I'll just kind of keep running with this. In explainability, there are kind of different ways, similar to performance, there are different ways to think about explainability. You can think about explainability as kind of a level of global feature importance. So across all my predictions, what were the most important features? You can think of it at a cohort level. So again, what were my prediction values across different feature value combinations? And what were the most important features for those cohorts? And then you can also kind of go as far down as an individual prediction level. So for a specific prediction, what was the most important feature influencing that decision, that model decision? And some common explainability use cases include, were my most important features drifting, or did they have any kind of data quality issues? It's important to remember that not all features are weighted equally. When understanding performance degradation, what is really driving those decisions? Was there any insights that I could gather from the rank of the feature importance values, whether I'm sending them in as kind of SHAP values or line values? And especially in more regulated industries, any decisions made by an automated system need to be justified and audited. So this is becoming kind of increasing importance. And I think there are some pieces here that I didn't even touch on, which I labeled here as kind of other considerations. There's lots of research going on in ML fairness, making sure your model is not discriminating against genders, races, socioeconomic statuses, or any kind of intersectionalities and minorities here. There's a whole kind of outlier detection section of this is are your predictions that are considered outliers not just out of range, but are they kind of multivariate? Do you have multivariate outlier detection as well? And then, of course, kind of its own plethora of use cases include unstructured data and how to handle high dimensional vectors. We're talking, 1,000 or 10,000 dimension vectors, encapsulating information such as audio, video, NLP, or images. And so that in itself is kind of worthy of its own presentation as well. And with that, thanks so much for tuning in. Really appreciate the time, and just kind of to give my awesome team a shout out. We recently raised a $19 million round, the largest Series A in the space. And so, it's a really exciting time, and we hope to see you at the next ML Observability talk.
All right, thanks everyone. Now we'll be moving into the panel discussion. I'll ask my panelists if they could do a share screen for this. Our panelists today, Rhea, Abigail, and Reed, will be tuning in a second, and I'll just be giving the intros. I'll give everyone a second to get started. And if anyone else wants to share their screen, make it a little bit more interactive, feel free to ask follow-up questions in the channel. All right, great. So we'll actually be having 4 panelists today. Welcome everyone. So for the next 45 minutes, we'll be having a panel discussion on responsible AI, operationalizing AI ethics from the inside out. So the goal of today's panel is to discuss for the audience how to approach responsible AI from an operational standpoint. So hi everyone, my name is Amber Roberts. I'm an ML sales engineer at Arize. I'm a former astronomer, and previously I was on Splunk's ML product org. Happy to be here today to moderate. I'd like to just briefly introduce our panelists so we can get started. Aparna Dhinakaran, she is a co-founder of Arize, and she's our CPO, and she was a former founding team member of Uber's Michaelangelo team. Rhea Miera, who you just heard give a great observability chat, is the head of product at Arize AI, and he spent the last several years before coming to Arize working on Google AI, so product research and machine intelligence there. We also have Abigail Hinwin from, you probably know her from her New York Times bestselling books. She's also a film producer and a leader in the AI thought and responsibility space. Welcome, Abigail. And our final panelist is Reed Blackman. He's the CEO of Virtue, which is a consulting company that empowers AI leaders to identify and mitigate the ethical risks of their products. So thanks everyone for joining. We're going to go ahead and get started. So if there's a question you want to chime in on, just use the like the raise hand reaction. So, and then I can call on you there, and then you can lower hand for the reaction. Let's go ahead and just get started though with Abigail. Hi Abigail, how are you doing today?
Good. Hi Amber, nice to see you. It's good to see everyone.
You. So we hear about AI ethics and responsibility as a broad topic. But where does that start? Does that start at data collection or model training or production environment or somewhere else?
Yeah, I think it's a wonderful way to start the panel. And I just want to say I'm actually in my hotel room in Taiwan. I'm here to film, and I didn't expect that it would actually overlap with the panel, but it's good to be here. My background is in law. I studied law and government in college and in law school, and then I worked in the government for a couple of years before coming out to Silicon Valley and then starting my career in venture capital, working with our AI startups. And I would actually say that the starting point is really trying to understand what is ethical, and that is something that we start learning in the classrooms at a very early age. We learn that in our interactions with other kids in terms of what we believe. It's almost instinctive. We say, hey, that's not fair. We get a sense of parity, of like tit for tat. But I think as we get deeper and deeper, and this is something that we debated endlessly in law school, is it's hard to come up with a definition of fairness, because you can construct many different types of societies. My favorite definition personally is like, what kind of society would you construct if you were to be later randomized into it? And I think that sort of thought exercise makes you think about, well, then if I get the worst position in that society, pardon me, how would I construct the society so that I could, be that person would be protected as well as someone at the top of society. And so there, in my background, my work, what I've done is I've tried to bring some of these thoughts to the table, and we can talk more as the panel progresses. But I work with the Partnership on AI with their Fairness, Transparency, and Accountability subcommittee, as well as their Transparency and Machine Learning. And I think the second place after coming to a stronger understanding of ethics is how do we surface all the questions? And I think Aparna's team is doing incredible work in the space as well as others.
Awesome. Thanks, Abigail. That was a great answer. I don't see any hands for chiming in for this one, so let's move on to the next question. How do you evaluate the boundaries of responsibility? Like, who is responsible for responsible AI? Is it all of us? Is it certain people at the top? Yeah, Reed, I saw you just unmuted. Would you want to chime into this?
Yeah, sure. So thanks for having me, everyone. Reed Blackman. I'm not a lawyer by training, I'm a philosopher by training. So I was a philosophy professor for over a decade and been researching, publishing, teaching ethics for over 20 years. And so Abigail, I know John Rawls well, not personally, but I know the guy. So look, it's easy to distribute responsibility in a variety of ways. Yes, there's some extent to which, junior data scientists, engineers, product managers, et cetera, bear some responsibility. At the end of the day, I don't think it's reasonable to hold any of those people responsible if they lack the institutional or organizational support to make the kinds of decisions and devote the kinds of resources that they need to create ethically sound AI. So from my view, it's great when, if you like, more junior people sort of bang the drums and say, we need to do this right. But they face certain kinds of realities and certain kinds of pressures, such that I would, unless it's particularly egregious, I wouldn't take them to be primarily blameworthy. Rather, senior leaders need to create the framework that gets implemented, scaled, and maintained in a systematic and comprehensive fashion. And if they don't do that, then the majority of the burden, 99% of it, lies on them.
Absolutely. That was, a great answer. Thanks for chiming in, Reed. I love the variety of backgrounds too, that like are, now on a panel for AI responsibility. Like that's amazing to have so many perspectives.
A question for
Yes.
you, Reed, maybe just to make it a little conversational. One of the things that we see as folks are one of the challenges we see as folks are trying to operationalize some of these fairness and bias detection of their models is, of course, first, I don't have access to the protected class information. That comes up quite a bit.
Sure.
Be able to calculate those metrics. But then there's this piece around the actual practitioners or the data scientists or the ML engineers who are on the ground. They're not taught any of this. How do you detect bias? How do you detect fairness? And you have, it's a relatively new research area, even if, as you think about it, right? Only in the last 5 or 6 years have we really begun to talk about what does it mean to quantify that and measure that. And so I guess my question really is, and you're probably, you wrote, if you guys haven't checked out, Reed wrote this awesome article in HBR, Harvard Business Review, about kind of what does it take for a company to operationalize measuring these AI fairness metrics. But how do you get that to start at an organization that already is deploying models in production and they don't think they have any problems? How do you actually, start pushing them in this direction? And it's a multi-org, multi-persona kind of, push. How does one get started?
Yeah, I mean, there's a lot of questions there. So look, one thing to say is that the kind of technology, the kinds of tools that you're developing and others are developing are absolutely essential in order to do the work. There's not a question about that. Yeah. You're right that, so questions about what constitutes fairness or justice or what counts as discriminatory versus just mere differential impact that doesn't amount to discrimination, those are questions that have been going on for a very long time, but you are right that how do we translate those things into quantitative metrics is relatively new. That said, I think a deep understanding of different conceptions of fairness and how to apply them in particular use cases helps quite a bit in that translation. And I would never say, the data scientists can just figure this out. So I think the tools are absolutely necessary. I don't think they're sufficient. One thing that data scientists need is support from senior leadership in at least 2 places. One is they need them to acquire or to use the kind of software that you're offering. They need the requisite tools. They need to be given the resources, not just the resources, but a kind of culture in which senior leadership says, listen, take this stuff seriously. Yeah. And then how do you get there? Well, look, I think you sort of know this already, really, is that senior leadership takes this seriously for the most part when they see it as necessary for protecting their brand, which it is. So the more we see, people talk about AI ethics, and I always like to distinguish AI ethics into, divide AI ethics into 2 categories. There's AI for good and there's AI for not bad. The AI for good people are like, we've got this powerful tool of AI. Let's solve, world poverty and bad distributions of education across genders. That's great. That's not what your typical chief data officer, chief analytics officer, chief data and analytics officer, CIO, whatever. That's not what they're doing, right? If they're gonna do this stuff, they care about AI for not bad, which is we're gonna do what we're gonna do. Let's just make sure that in doing it, we don't totally ethically screw things up, which is also bad for our reputation, which invites regulatory investigation, which invites lawsuits, right? So for them, it's a matter of and look, some of them are good people and they want to do the right thing, et cetera, et cetera, et cetera, but they often don't have budget for just doing the right thing for the sake of the right thing. So the senior leadership starts to move when they understand that if we don't get AI ethics right, in the sense of AI for not bad, we're putting our brand at risk.
Yeah.
And once they understand that, then yes, then they're going to give the data scientists the support and the tools that they need.
I think one of the things, at least when we chatted before, that you said that's really stuck with me is you think about security orgs in a company today, like security orgs that look at things like data, my data being sent outside is going to be a risk to my business. And there's structures in place so that there's a security org, there's a head of security. They're given, here's the things that you need to protect against. Each team now has certain requirements as part of the code that they push to actually mandate data privacy requirements. And I think one of the things that you said that really stuck with me is we need to get to that for AI because it is another area of risk for a business. And I think thinking about it in that framework has been helpful as we have something from a security and data privacy perspective that we've implemented and is now seen as a normal part of software building. And that's what needs to happen for AI ethics.
Right, right. So, and you had an education of senior leadership, right? So they went from, and some of them still think this way, although it's getting better. They think cybersecurity is give those engineers some tools.
Yeah.
Like they just need some stuff to keep some stuff secret. That's what they, right? And what people have learned is that, no, you need something like a CISO who can do a cybersecurity strategy. There's lots of stuff to talk about. There's lots of ways you can build your strategy depending upon the kind of organization you are, the kind of risk appetite you have, et cetera. And then, yes, you give those tools to the engineers so they can execute on that strategy. But absent a strategy, just throwing tools at the engineers isn't particularly helpful because they're just going to drown not knowing which of the many directions should I go. And it's the same thing with the AI ethics. Yeah, you absolutely need the tools so the engineers, the data scientists can do that work. But if you don't say, listen, strategically, here's what we're trying to accomplish, and here's how we're going to accomplish it. And by the way, here's how there are various kinds of organizational supports for that thing, like aligning financial incentives with quarterly, aligning financial incentives with AI ethics in relation to quarterly and annual evaluations and promotions and bonuses, stuff like that. When you have all that stuff in place, then the data scientists not only have what they need, but they're highly incentivized to use that stuff.
Awesome. Thanks, Aparna and Reed. Like that's going in like the cybersecurity side of it, like is more and more present. I have a question now for Abigail. So one term that the World Economic Forum puts in its guide to AI fairness is AI governance by design. Like, what does that mean to you? Like, how could that be accomplished? Like, do you even think AI governance by design can be accomplished?
So I think this, the question actually segues really well from just the previous conversation. Like, I absolutely agree that a lot of the push, we need to have senior buy-in for AI ethics and then and AI responsibility. But I think the point was made on the previous discussion that there's no one solution for everything. And so I actually do think, especially with this, with the folks here who are attending this conversation, responsibility for responsible AI lies with everybody up and down the chain, because we are still so early that we don't know where bias or safety issues or fairness issues will arise. So Partnership on AI actually has a database that they're collecting called incidentdatabase.ai, and it's a place where people can go and submit, anyone can go and submit concerns that have come up in the AI space. And we have the hot button issues now. We know about cyber terrorism, we know about privacy issues, we know about implicit bias, but I think that's a space that still needs a lot of work. And so because there are still so many areas that haven't been surfaced, things that we're still learning, it's hard to come up with something that's cohesive. And unfortunately, we can't build ethical AI in a vacuum because, as Aparna said, it's already been being deployed. So in some ways, we're trying to make sure it's being built properly. And I think that's where this concept by design comes in. Yes, I think I said it would be all of the above. We do need AI by design, but there's also going to be other mechanisms and other tools that we need to approach the same problem. And again, it has to be up and down. Everyone has to take responsibility for it, regardless of whether your org has those structures in place. Although I do believe every org needs them.
Abigail, sorry, one question I have for you, especially given your background, I think even for tech, for folks on the engineering side, sometimes it's overwhelming to think about how to measure fairness. How do you recommend kind of that cross org kind of, you know, across from legal, given your background, to how do you recommend kind of that? It's not similar to security from kind of that vantage point of it's not just from an engineering perspective that it impacts the entire org. Um, how does an org kind of start thinking about it from multiple different, you know, types of approaches?
I absolutely agree that the one engineer who is working to get this out, before the competitor gets it out, it's hard for them to be thinking about how to solve all the problems of the universe, which in some ways this conversation raises, because it does allow us to step back and say, hey, look, there's been implicit bias embedded in these systems, in our human systems for years and years, and it's the AI and the models are bringing it to light. I think it is important to have these partnerships between legal and ethical departments, between social scientists and really everyone who is thinking about these questions together, and to understand like how can we construct internal policies as well as external, like governmental policies that can help facilitate ethical development, can facilitate in a helpful way rather than a way that's crippling the technology. And there's always been this discussion between governance and innovation. I don't believe they have to be in conflict, but there are places where they may seem to be. So I think if it's a small company, there are resources like what you're building. There's the Partnership on AI. There's a lot of wonderful nonprofits out there that are doing a lot of thinking around the space and how to operationalize. And so I think those are freely accessible to everyone. We can start to tap those resources. I love when companies bring in outside consultants who are developing expertise in this area. And then there are companies who are creating AI ethics committees at the highest levels of the corporations. And those are another way that community can be built around it. And for sure, having those voices invested in every step of the development process and then on to deployment is really important.
Thanks so much, Abigail. The next question I have is for Rhea. So you came from Google AI. Before that, you were at IBM. At the present, do you feel that there are any companies making large efforts or initiatives to be responsible with their algorithms? Like, are they even in a good spot? Like, is there more they could be doing? But like, are there any making these large efforts, and like, what might those efforts look like?
Yeah, that's a great question. I did help kind of spearhead the Google's Responsible AI initiative within the Google AI org. But I really like the way Reed put it, which is like there are companies that are kind of doing good or socially beneficial, and then there are companies that are doing not bad, kind of splitting them into two categories. I think in general, and I'll speak kind of just based off of my most recent experience at Google, I think, and truth be told, it's actually a result of a number of really bad blunders or hiccups that caused a great deal of not just user churn, but massive PR blunders. There's been a number of principles that have been instantiated from a top level down towards each team across Google to really incorporate socially beneficial principles into AI tech, to make sure that they're actively monitoring and creating kind of checkpoints to ensure there isn't any sort of reinforcement or unfair bias. So there are a number of practices that are working to mitigating unfair bias. But when I think about kind of how Reed classified it, there's not a lot being done when it comes to incorporating and preserving privacy by design. So what about our kind of user data? How is that being used? And I'm talking kind of going one step beyond the terms and conditions that nobody reads, right? When you use Gmail and you sign up for these services, what's actually happening with your data? How can you have a more transparent window into the way your information is being leveraged against you, whether it's to deceive or even manipulate you into making a purchase or voting for a candidate, right? And so this is there, I guess, to summarize, I think that there are a number of principles that are being now enforced for the sake of mitigating unfair bias. But when I think about the differences between doing good and not doing bad, I think there is a lot more companies can do from a top level down to individual teams.
Yeah, can I say two things on that?
Yeah, go ahead.
Yeah, yeah, that was great, Ray. Your name is fun for me because my wife's name is Leah and I'm Reed. So sometimes, and then our daughter's name is Riva, and so people think that like Riva is a combination of Reed and Leah, but in fact we would have named her Raya, I guess, is what we would have done if we were that narcissistic. So two things. The first thing to say is that yeah, there are all these high level principles. They strike me as total nonsense is a bit strong. Vacuous is probably more accurate, right? So we're for fairness. Great. You know, the KKK says they're for fairness, right? If you write a piece of paper that says we're for fairness, the KKK will be like, yeah, 100%. And what's fair is for the white man to blah, 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 you know, some morally odious conception of what fairness looks like. So saying that you're for fairness and saying it's really important to you is really, that's not even table stakes. That's just it's nothingness. It's nothingness. Same with we're for privacy. Okay, what do you mean by that? Do you mean that you're not going to show people things? Do you mean you're going to give users ultimate control over all their data? Do you mean that you'll give them control over their data, but you'll restrict services as a result? What are you saying? So there's one question about what are these principles actually, and more often than not, they're very little because it commits them to nothing. Right? If you're going to articulate some principles, then you better articulate, for instance, some guardrails. These are the things that we will always do because we respect privacy. These are the things we will never do because we value fairness. So you have to set some guardrails, or else don't tell me that you value something. The second thing to say is one thing, and there are some companies that are doing some great things to your original question, Amber. So for instance, I think that Microsoft takes it really seriously. I think Salesforce takes it really seriously. And I'm fairly familiar with people. I know a bunch of people who work at both of those places, so I'm fairly familiar with what their operations actually look like, as opposed to what their external facing documents look like. That said, I have yet to come across a company, and it's hard. I'm not saying it's easy. It's very hard when your ship is as large as Microsoft's. Every single one of our products goes through some kind of ethical review. Every one, right? Who says that? I mean, Microsoft has that for various, particular use cases. It goes through that for highly sensitive cases. Google has some version of this, but it has to do with their partnerships, like what they build for other people as opposed to what they build internally, at least as far as I understand, which is very different from, say, the kind of thing that you see in medical research, where everyone who's going to do medical research or testing on human subjects needs to seek and acquire IRB, or institutional review board approval. Every single one, right? So there's an extent to which when we say, yeah, they're doing things now, they're checking their products, I want to know what % of every ML that you train, develop, ultimately deploy is going through some kind of ethical assessment. 50%, 25%, are you tracking this? Are you trying to, is this a KPI that you're tracking and you have certain goals around it? Or is it just sort of like, yeah, we do it sometimes. We're not sure when, and we have no goals.
I think that the one operational thing that I think everybody needs to implement is hiring diverse people. And, I think Aparna mentioned that. It was mentioned in the previous panel as well, but if you have diverse people working on these, then they're the ones who are going to identify like, hey, this product isn't working for me. This facial recognition algorithm does not work on dark skin. The demographic that I come out of in this particular area is not represented in the products, and it's not reaching, this group of people. And I think that there is no substitute for that, because we don't know what we don't know. And if we don't have those different voices and give them permission to speak up and permission to point out these areas that there are gaps, then that's when we run into problems. But I would say another big area is safety. So AI technology, being a multi-use technology, can be used for good or evil, if we want to use those terms, or harm or less harm. And some examples would be lip reading technology for the hearing impaired, can also be used for surveillance. And so companies need to put in that sense of like, okay, we need to check to see before we deploy our research, before we deploy our products, what could it be used for? And that's just a basic level of responsibility, which could have a very large impact on other people. But there are other things that, like implicit bias embedded in our systems, that initially on the surface may not seem like a big deal, and they may be easier to overlook. But over time, because we're designing a system that is biased, back to the point about ethics by design, that can actually cause larger and larger harm, such as creating information bubbles that can eventually sway elections or create this polarization that we're seeing now, not only in our country, but in other countries around the world.
That was a great point, Abigail, especially like the inherent bias from just, starting at the beginning. That actually leads really well into my next question. And then we actually have a question from the audience to follow this. But a recent headline suggests like ML teams need to fight bias with bias to combat things like implicit bias in training data. Let's just start with Abigail, because I think everyone can kind of touch on this. Like, what's your initial reaction to that? Like, do you think we should do that? And like, is that something we achieve in practice?
I think I don't know if I fully understand the question. Fight bias with bias. What does that
mean?
Like
fighting bias with bias to combat things like implicit bias. So like, if if you see bugs that are happening, like instead of it just being like, so when someone like trains model on like, okay, like top 10 images, you're like upsampling too, to try to get like a fully like diverse data set. But like, even if it's not necessarily representative of, I don't know, like kind of the data as a whole, essentially, like if you're trying to, like, the bias doesn't come because someone put it in there. It comes from like not realizing, or, just having a lack or a blind spot in your data. But that can, occur naturally. Like, it's finding those and trying to retroact those in the process, like what we should be doing. Does that kind of clear it up?
Yeah, no. So this is a really big question mark, right? And it's one of those big societal questions that we haven't solved yet. Like, do we address systemic issues? Who pays for systemic issues that have been, around for thousands of years, hundreds of years? It is a slippery slope, right? But yet we do need to do it. Like, for example, like there are some very clean examples of the algorithm that does not correlate women with leadership roles for human rights or for human resources, right? For hiring practices. So clearly that's something that needs to be addressed, and is not easy to address. It's not a matter of simply just removing gender names, or because there's a lot of there are other gendered activities that are just kind of embedded. So someone, there's probably more women ballet dancers applying for AI roles than there are male ballet dancers, although there may be, and I think that those norms are changing over time. But that would be an example of where, we could probably go in and say, okay, let's add more examples of women in leadership roles so that we can have more parity. We're addressing for historical bias in the data. But there are other constructs which are really harder to address, and even the law, I think, is still figuring it out within protected classes. There's race, there's color, there's religion, there's gender identity, sexual orientation, marital status, medical conditions, there's military status, veteran status, ancestry, disability, and there's just so many that are not all given equal protection within the law. They're given different weights, and so I think it's very hard for companies to figure out how to navigate this. And before we go inserting or rebalancing, I think this is why it's really important that the person making these choices is really well informed through people who have been doing a lot of thinking on it. So again, back to the nonprofits, the organizations, the think tanks that are doing a lot of research in the area.
Yeah, exactly. And like, what's actually perpetuating stereotypes or, bias in these algorithms. Thanks, Abigail. So this is actually a question from someone in the audience.
Sorry, can I jump in with a
go
slight?
for it.
Yeah. I think some of what I'll say is intentional with what Abigail had to say, which is not to say, anyway, I'm just going to put a different view out there. Number one, going by that headline, the first thing that springs to mind is that the person who wrote that headline doesn't know what they're talking about, to be totally honest. I mean, so look, when we're talking about bias in AI, what we're ultimately talking about is discriminatory outputs. When we're talking about implicit bias, we're talking about a certain alleged psychological state, where the psychological state is something like, by virtue of being raised in a certain culture, yada, 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 people have certain kinds of implicit, that is to say, not readily accessible to conscious thought biases that make them, and that's the first claim. The second claim then is that those implicit biases play a role in actual behavior. Those are both empirical claims. They're actually both highly contested, especially the second one. And besides that, all that talk, all that research in psychology on implicit bias is not the most obvious explanation, or is not obviously relevant to how we wind up with biased or discriminatory AI. First of all, there's a number of ways in which you might have a training data set that results in discriminatory outputs. It might be because of proxy bias, it might be undersampling or oversampling. It could be where you set your threshold, it could be how you weighted your variables. It could be because the objective, that has nothing to do with your training data set, it has to do with the objective function that you chose. Like you chose to maximize, for instance, quantity of years saved with how you distribute organs. And it turns out that Black people have a worse mortality rate than white people. So you start giving all the lungs to white people instead of Black people. It wasn't your training data set. In fact, Black people do have worse mortality rates than white people. That's just a fact. It might be more than likely is downstream of certain kinds of racist problems, but the problem is with your objective function, not with your facts about people's mortality rates, which are actual. So that's me saying a couple of things. One is I don't think the talk about implicit bias makes a ton of sense in talking about how we wind up with discriminatory models. The second thing to say is that there's lots of ways we wind up with discriminatory models. One is because we have a certain kind of training data that leads to that output, but there's also loads of other things like where you set your threshold and what your objective function is. So if we think that, okay, look, we tackle bias by tackling bias in training data sets, the focus is way too narrow. You're still going to wind up with loads of sources of discriminatory models. Okay, that's my short rant. I have more to say, but people,
Are you sure you want a lawyer, Reed?
Yeah, no, I would like.
Philosophers are like lawyers.
Yeah, no, I absolutely agree that there are many factors that should be tackled, and we should be looking at everything that does contribute to the biased outcomes. I do think that implicit bias is something that is easily overlooked because it's not easily understood, and until you actually have some. So I'll give an example. I clerked for Judge Judith Rogers on the DC Circuit. She was one of the first African American women to be appointed to that court, and also served on the hiring committee for Harvard Law School. And at the time, they had very few female applicants that were getting through the gates. And the response from her male colleagues was, "Well, they're not qualified. They don't have Supreme Court clerkships, and we want all our faculty to have that experience." She said, "Well, they can't get Supreme Court clerkships because they're not getting hired in the same numbers in the Supreme Court, right?" And
Sure.
so that's an example, right, of systemic bias. And I think that one is more easily understood. But I think the implicit bias, like when we drill down, we all have implicit bias that we've grown up with, that we see on the media, that we've read in books, and the entire cultures are shaped around certain biases. And those, if we don't look at the way that, and actually I found that what's happening with AI models is that because they are working with such large swaths of data, they're actually able to surface some of these things that were inherent in our history. And I think so that's the hard question, right? If we have identified, what do we do with this information now? Now that we've identified there is this historic implicit bias embedded in our systems, and now we can build tools. Are we going to build tools and employ tools that are going to operationalize the discrimination that we already see there? And I think that's where we have an ethical obligation to address it. But I also agree it's hard.
Yeah, sure. I mean, so look, suppose you have a case in which, let's just take the case that you referenced earlier, the Amazon hiring algorithm, right? Mm-hmm. That they junked after 2 years, which people slam Amazon for, but I think that's unfair. I think they actually, they scrapped the program after 2 years. I mean, it's impressive what they did. They said that we can't sufficiently be biased, so let's toss it. But anyway, so you've got this data set, and the algorithm, the pattern it learns roughly is we don't hire women around here. And now you have to figure out, what do we do? What's the appropriate bias mitigation strategy, right? You might do that while remaining agnostic about how the training data set got to be the way that it is, right? It might be the result of the implicit biases of hiring managers. It might be a pipeline problem, which is itself downwind of certain misogynistic, sexist policies and practices over the centuries. It might be because men lied more on their resumes, and so they get more interviews. It could be all of those reasons and more for why the data set got to be the way that it is. And there's a variety, in general, there's a variety of explanations available for why data sets look the way that they do. It's not, knowing those kinds of things are very useful for forming hypotheses about where we might look for sources of discriminatory outputs in our training data, but it's not necessary. It's not a necessary condition for formulating the correct bias mitigation strategy. Right? So maybe the bias mitigation strategy is we should, you can see something like this. I don't know how exactly this got this way. It's a complicated empirical question, but I think that the best way to mitigate the bias is to go get more data about X, or to create or use synthetic data, or to change our objective function, or to change our thresholds, or to modify our weights, right? There's lots of what the appropriate, it's not obvious how the explanation for how your training data set got the way that it is, such that it results in discriminatory outputs, informs what the appropriate or best, most effective, efficient, et cetera, bias mitigation strategy is.
Awesome. I like that we're really diving in to this discussion and having some back and forths. So the question from Zachary in the audience was kind of going back to the companies and the responsibility they're having for AI in practice. So enterprises looking at these problems face choices as to whether they will build their own tools, proprietary or using open source, or buy solutions to address these issues. So from startups to larger incumbents, what do you think will be the key factors that will affect their decisions on the tools they adopt moving forward? And this can be kind of for anyone, but Rhea, if you want to kind of chime in for what kind of key factors will affect these companies' decisions on which tools they adopt for the responsibility.
Yeah, I mean, this is a great question. I think that just given that this is a fairly early space, and we're seeing constant new technology come out on a daily, if not on a tweet basis. I think that open source is a huge proponent of making sure that your code is viably tested and scrutinized by third parties and unbiased organizations. I think that's a huge plus to have. I also very much believe that the level of granularity, so something that I quickly covered in my presentation was global, cohort, and individual level explainability and importance, is one that's crucial. So what type of features are you able to provide and present using your ML observability toolset or explainability toolset? But ultimately, I think, when making or deciding on trading off between building something in-house and recognizing that there are dedicated, well-funded teams whose entire kind of passion and focus lies on building scalable tools and technologies for this purpose, is realizing that one-off scripts and ad hoc graphs are not going to cut it for this type of scrutiny and being able to really deeply understand how your ML model is behaving, whether it's biased, whether it's socially beneficial, whether it's privacy oriented, how decisions are being made, and whether you can reproduce them, and what's affecting those model outputs. But I think being at Google AI, being at IBM's Watson Group, the mantra was the same. Taking a model and being able to explain what's going on in a controlled research environment is very different than in the real world, where you're dealing with corrupt, bad data coming from upstream, when you're dealing with surrogate models and the output of one model is the input to another. And the complexities kind of layer like an onion. And so I think it's not an easy choice to make, but it is a full-time, round-the-clock job that requires a high degree of scrutiny at a global, at a cohort, and on individual prediction level. And so, you know, there's struggles with open source being well funded and having a viable kind of business, a viable kind of business strategy to make sure that it's keeping up with all the needs of a kind of big Fortune 100 company in order to satisfy these strong, responsible AI principles. And then on the other hand, you want to make sure that as a proprietary piece of software, you're being well audited and being truthful in kind of what you're offering and how you're handling data. So it's kind of a really good question. I'm curious to hear if others have opinions on this as well.
Yeah, Reed or Abigail, did you want to chime in?
Yeah.
Okay, awesome.
I mean,
yeah, that was a really good answer.
Yeah.
It's okay. I think it really encompassed, yeah, every part of that.
I'll just say one thing, which is, and I sort of, you know, I'm not selling this kind of thing, so I don't have to be subtle about it. You'd be crazy to just try to let's build our own thing. It's going to take several years to do. It's going to be really expensive to do. And we're going to put ourselves at risk for all those years during which we're building our own thing and not using someone else who's already built it. What is the possible? I mean, maybe it saves you money in the very long term, but that seems like just a really bad strategy to do nothing for several years and put your bets on an internal team that they're going to be able to develop it really well and in short enough order before anything bad happens. Why place that bet when you've got viable solutions already on the table? And even if you think they're not perfect and you do want to build your own thing internally, okay, fine. Until you do that, use the stuff that's already out there, because there are real harms to be avoided now, and there's real reputational loss to be avoided.
Right. And so we are at, we have about 6 minutes left. There's a few more questions I want to get through, including like individual ones for the panelists. So Abigail, this question is for you. So ensuring responsible AI is an ever-evolving practice. How do you keep AI ethics front of mind as you help create these strategic partnerships that focus on next-gen AI technologies?
You know, I think it actually goes back to something Reed said from the beginning. We need buy-in from the very senior leadership. So if it's not the CEO, there's some other AI ethics officer on the board or on the in the C-suite who's there to, whose responsibility it is to make sure this is a priority for the company. But barring that, because we don't have that in every company yet, then it is, and then I think it's everyone's responsibility, everyone who touches it, to be thinking about these issues. And you know, I think it's like a way of life. Like we go about it in our own daily lives, like trying to be fair when we, you know, navigate conflicts between our family members and our kids. And, you know, that's the same thing that we're going to be doing as we approach our work.
Absolutely. Reed, this question's for you. So as someone who empowers AI leaders to identify and mitigate risks in their products, what are some top 3 pieces of advice you tend to like give across the board, so like everyone tuning in can like also take that away?
So, okay, a few things. So the first thing is, generally what happens is, I think one thing that I try to stress more and more is, before you jump into action, you have to understand the issue. So what you have is, right now we have really scary headlines, you know, and people say, rightfully so, bias is bad, black boxes are scary, privacy violations aren't acceptable. And then quick, do something. And that is way too quick, right? I mean, that's like saying, hey, we discovered this thing that we're going to call cancer. Quick, it's really bad, do something. And it's sort of, you know, what you want to say is, hold on, let's understand the problem. Let's understand the source of the problem. You're not going to start throwing drugs at people because you see that they have cancer and it's bad. You've got to understand what's the source of the problem? What is this cancer thing? Where does it come from? Or what are the number of sources that it might come from? And it's the same kind of thing in AI ethics. We've got biased or discriminatory models. We have black boxes. By the way, sometimes that's totally acceptable from an ethics perspective. Sometimes it's totally unacceptable. Some things with how you think about privacy violations. What are the sources of those privacy violations? When explainability is verboten, why is it? When it's really important, why is it important? When it's not important, why not? When we get discriminatory algorithms, how do we get models? How do we get them? How do we get there? And what I try to stress to everyone is that you can't jump to the solution without having a deep understanding of the problem or the problems and the sources of those problems. And without that understanding, you're not going to develop a robust, systematic, comprehensive risk mitigation strategy. Just not going to happen. And so the first thing I want people to do is just hit the brakes for a second, make sure you understand the problem before you start developing solutions. That's the big thing.
And let me add to that too, because I think there's a really important dynamic here. One of the things I think a lot about is how do we bridge this huge divide in our country right now? Like there are, there's vaxxers and anti-vaxxers, and for some reason there's a complete disconnect. And the same thing with gender wars, right? There's critical race theory, right? Suddenly, like our country is divided on so many issues, and I think part of the urgency that arises is that there are people who've lived these experiences for so many years. They see way down the track to the crash that's coming, and they don't want to live these experiences anymore. And so I think that's where the urgency is coming from. Like we need to act fast. And so what is the solution? I think the people who don't understand, I think often that's a privileged position to be in. Like, wait, we don't understand. We don't know why this is unfair. We don't see it. Let's take time to figure it out. But that's because they don't experience it themselves, right? And so that's where it's important to look to organizations that have spent a lot of time and energy and resources and thought power to develop concepts around this, and to hire them if you don't have them in-house and you haven't, because it's a luxury to say, let's take time to figure it all out. Meanwhile, the train does.
Is it a luxury for now? Was that something you were going to comment on, Reed?
Well, I don't think that I think it's a necessity if you're going to solve your problem. I'm not sure that I'm not sure it's a luxury. Look,
I think for a lot of teams now,
it's a luxury.
They treat kind of ML observability and AI ethics like as a luxury, whereas eventually it's going to be a necessity, and there's certain countries that are trying to make it more part of like the security process. But yeah, that's just a quick follow-up for you, Reed, on that. When does it become a necessity? That's what I think what a lot of companies are struggling with.
I don't know how much they're really struggling, honestly. It's not
what they say they're struggling with. No.
It's not that hard. Look, here's my actual view. It's not that hard. Like, it's hard. It's not that hard. There are, to Abigail's point, plenty of people who have studied this stuff, who understand this stuff, and who have a good grip on what to do, right? It's a matter of will. It's not a matter, if I promise you, if the C-suite says, we need to get serious about this, they will get the right people in short order to help them figure it out if they don't have them already, right? So it's not just the sort of, we have no idea what to do and there's no one who can help us. It's absolutely a lack of will. And that's because they don't yet see that the problem is real. They've seen some headlines, but they're like, well, that's probably not going to happen to us. Or they've seen the headlines and they're like, let's wait to see what the other companies do first. And so you see tech companies who are leading the charge here because they see their peers getting in trouble. And then when you see healthcare companies and financial services companies getting in trouble and they're in the headlines, that's when you start to see those sectors taking it up. And once marketing companies start getting in big trouble for discriminatory algorithms, then the marketing people so they have to be able to see themselves in the headlines, and that's when they start taking things seriously.
Right. Okay, I do see we're out of time. I want to get this one more question that's just, the main message, just in 30 seconds, for Rhea, Reed, and Abigail. What's the main message you want the audience to take away? If you do have calls after this, thank you for joining. We're just going to get these quick takeaways. Aparna's having some connectivity issues, so we'll just have it be the three of you. So 30 seconds. Abigail, let's start with you.
I think everyone is responsible. Everyone can put their best foot forward. I understand we're in a state of where we're deploying, we're developing, we're innovating at the same time that we're also trying to figure out these big global ethical questions. And so I think the bar that I try to say is like, are we doing better over time? Like, is what I'm putting out better than the baseline of what humanity has come together on its own? Are we improving society with our work rather than perpetuating or moving backwards? And I think everyone can be responsible for that in whatever sphere of influence they have.
Definitely. Thanks, Abigail. Reed.
So I guess in this context, I think the main takeaway is I think that the tools that Arize has developed and other organizations have developed are absolutely crucially important, and we need to push senior leadership to create the conditions under which tools like that are taken up, used effectively, and not limited to, and the overall problem is not limited to just data scientists. It's data scientists who use those tools in conjunction with other people, lawyers, ethicists, et cetera.
Great. That's a great takeaway, Reed. Rhea, chiming in for the kind of last takeaways from things for people to keep in mind.
Yeah, I think Abigail and Reed did a great job. I think, use a human-centered design approach. Continuously monitor and measure multiple metrics across training, across production, across validation, again, kind of global cohort and prediction level metrics. Look at your raw data and really be honest when assessing and trying to understand the limitations of your data sets and of your model. And I think kind of the core message I want to send is kind of what's good today will not be good in 6 to 12 months from now. And so this is a practice. This isn't a checkbox that you just mark off. So you'll be continuously improving your models. And as a result, you need to be continuously assessing different metrics, bias metrics, and mitigating, ensuring fairness as a practice continuously.
Great. Well, thanks, panelists. Thanks, all the participants. I know we went a little bit over. Thanks for everyone who stayed to the end. Hope you all have a great Tuesday. Bye.